Welcome to our session on probability. So probability has a number of distributions. We call them probability distributions. Among them is what is called the discrete random variables. Discrete random variables has values of x that are defined. 1, 2, 3, 4. They are defined. So we'll be asked to calculate the mean, the standard deviation, and the variance. So before we do the example which is here, I'll give you an example that I will try. Now this is one distribution where I can simply write without explaining and you get it because it's the simplest. So we're given the values of x, 1, 2, 3, and 4. And we're given the probabilities, 0.4, 0.1, 0.3, and 0.2. And you're being asked to find the mean, the variance, and the standard deviation. So this is carrying about 10 marks. Right, so to find the mean, this is column 1, and this is column 2. So firstly, to get column 3, we can square this, x squared. What do we have here? 1, 4, 9, and what? 16. Owing 191,400 because it has accumulated an interest. Then we'll be asked to calculate the mean. The mean will simply be column 1 times column 2. So we can call this column 4. So when we apply this by that, we're going to get x px. So what we're given originally were the values of x and the probability. Now for a discrete random variable, you need to make sure that the probability is adding up to 1. So to get this column, we're going to multiply 1 times 0.4, get 0.4. 2 times 0.2, 2 times 0.1 is 0.2. 3 times 0.3, what do we get? 0.9. 4 times 0.2, we get 0.8. So the total value is what we call our mean. So this is summation of x, px, just sum up. So what do we get when we sum up this entire column? So this is 1.9, 2.3. So the mean, which is denoted by any of these three letters, you can use mu, you can use e, not summation, but the letter e with an x there. Or we can say summation of x px, it's the same thing. Summation of x px. So our mean in this case will be 2.3. Then to find the variance, column 5, we're simply going to multiply column 2 times column 3. So this by that, x squared px. So this is going to be 0.4. This is going to be 0.4. 3 times 9, what do we get? 2.7. And 0.2 times 16, what do we get? 3.2. Then we sum up. So when we sum up, this total will be 17, 31, and 6.7. So this is called summation of x squared px. So our mean has been found as 2.3. But B, how do we find the variance? The variance is simply this minus the square of that. So our variance of V of x is simply summation of x squared px minus the mean. The mean, which is summation of x px to the power 2. So 6.7 minus 2.3 to the power 2. What do we get? 6.7 minus 2.3 squared. Pardon? 1.41. Then part C, they'll ask you to find the standard deviation. The standard deviation is simply when you square root the variance. So let's square root the variance. What is square root of 1.41? What is the square root of 1.41? So standard deviation will be 1.187. So this is how we find our standard deviation. Then part D, you'll be asked to find the probability of x is greater than 2. So you go to the values of x, which values are more than 2. It is probability of 3 and probability of 4. So the probability of 3 plus the probability of 4. So what is the probability of 3? 0.3. And what is the probability of 4? 0.2. When we add these two, we get 0.5. That is the probability of x greater than 2. If they say probability of x greater or equal to 2, so we're starting from these two, 3 and 4. We are adding the total of these ones here, which is 0.6. About probability less than 2, less than 2, we only have what? 0.4. Any questions at this point? Any questions at this point? All right, so I'll ask you to try this question here. I'll give you only 5 minutes. Try this question. It was carrying about how many marks? It's carrying 3 plus 4, which is 7 marks. So quickly try, and we will discuss it. How do we find our mean?
Our mean, so as from the example we had, we have a number of bedrooms, which would be our x. Our probability would be our px. So we have a formula for mean, which is the summation of x is equals to summation x px.
So here, x px and x squared px.
Yes.
So how do you find the values of x squared?
We're squaring x, which is our number of bedrooms. So 3 squared, which is 9, 4 squared, 16, 5 squared, 25, 6 squared, 36.
Okay. And how do we get this column?
We are multiplying x by px.
What are we getting here?
Which is 3 by the first one is 0.75, 3 by, yeah. The second one is 2.2. The next one is 0.75.
0.75.
The last one is 0.3.
0.3.
Yes.
Okay.
So we are supposed to sum x px.
What do we get?
We get 3.4.
3.4.
Yes.
Okay, so that is our mean. That is how we find the mean. We simply multiply it by that. So our mean is 3.4. Do we agree?
Yes.
The next team, how do we find the variance? How do you find the variance, Sharon and Tim? How do you find the variance?
Summation x squared px minus mean.
Okay, so how do we get the last column first of all? This column here.
X squared times px for each column, and the first one it will be 9 times 0.25.
Which is what? Yes, Mwaka?
Sorry, I don't know if it's listening, but XPX for
The first one is 2.25.
2.25. Mwaka, you're saying for the XPX, what did you?
I'm finding 4. I don't know if there's something wrong with
4 when you total up?
Yes.
Okay, somebody clarify what she's querying. 0.75 plus 2.2 plus 0.75 plus 0.3 equals 4, yes. So thank you for that. This is 4.
I also find 4.02, I think.
It's just 4 exactly. All right, then let's go here. We'll be multiplying 0.25 times 9. What do we get? 2.25. 0.55 times what? 16. What do we get? 8.8.
8.8.
0.15 times 25. What do we get? 3.75.
3.75.
0.05 times 36. What do we get?
1.8.
8. So when we add all these,
1.8.
1.8 plus 3.75 plus 8.8 plus 2.25. What do we get?
16.6.
16.6. So
16.6.
how do we get the variance?
8.
How do we get the variance? Variance is given by what?
Variance.
What's the formula for the variance?
16.6.
Summation of x squared px minus what? The mean to the
Minus the mean.
So 16.6 minus what? 4 squared. Which is 16.6 minus what? 16, which is 0.6. So how do we get the standard deviation?
Square root.
Square root, the variance. So when you square root our 6.6, 0.6, what do we get? 0. What? 77. And now what is the probability x is greater than 4? What is the probability x is greater than 4?
.20.
Which values are greater than 4? 5.
We are adding.
2.2.
Yes. So the value is greater than 4 with the probability of what? 5. And the probability of what? 6. Which is 0.15 plus 0.05. So when you add these two, we get 0.2. So that is the probability x is greater than 4. All right. So your homework will be question number 1. You find the mean standard deviation of this. And this is variance and standard deviation because the mean has already been found. Okay. So this is under what we call discrete random variables. Discrete random variables. Now we'll look at another probability distribution which is called normal distribution. So normal distribution, to start with, has 3 characteristics that you need to know. Number 1, the distribution is bell-shaped. It looks like this. Number 2, can you tell me the characteristics of normal distribution? Number 2, it is asymmetrical. What does it mean to be asymmetrical? Each side mirrors the other side. So here you have 0.5 and here there is 0.5. Number 3, the area under graph will be what? 1. Okay. So this is what it means to be normally distributed. So we are going to learn the standard formula for normal distribution, which is x minus mu over standard deviation. This is how to standardize. This is how to standardize this formula. Okay. So now, before I go any further, I need to teach you how to read the tables. I need to teach you how to read our normal distribution tables. Okay, so let's go to our we have our normal distribution tables with us. Let me broadcast the normal distribution table. So the normal distribution table looks like this. So this is our normal distribution table. So when you're asked to read the normal distribution table, there are two types of normal distribution tables. Okay. So there's what is called the cumulative and the non-cumulative distribution. So for the cumulative, the reading starts from this end up to over the other side. So if I ask you to read for me 1.23, 1.23. So you go to 1.2, the first two decimal places here, and 0.03 here, where they meet. So the reading will be 0.89065. So help me, how do we find the reading for 1.64? 1.64. Who wants to try the reading for 1.64? You check 1.6 and 0.04 where they are meeting. 1.6 and 0.04. So this is a reading. Now help me find the reading for 2.33. The ladies and the guys, help me find the reading of 1.27. Quickly.
2.33. 2.33 is 99010.
What's the reading? 1.33? Huh?
99010.
Under 2.3 and 0.03. Yes. 99010. Correct. The guys, 1.27. How do you read this? Yes, the gent, what is 1.27?
98840.
You go under 1.2 and 0.07.
Yeah.
98.
840.
Where's the 840? I can't see it. 0.98796, isn't it?
Mhm.
Now, I want you to try the opposite. I'll give you the Z. I'll give you the probability, you give me the Z. For instance, this is the probability, 0.89796. So what is the Z for this? You just simply go and add the 1.2 and the 0.07. So it will give you 1.27. So give me what is the Z for 0.98500. What is the Z for this probability?
2.17.
2.17. Excellent. Sometimes the figure may not be exact, but the closest possible. For instance, what is 0.981? This is it for 0.981. So you can pick this one because it's the closest. What is the Z? What's the Z for that probability?
2.17. 0.06, I think. Did you underline?
What is the Z figure quickly?
Which one did you
That's
underline?
mine.
2.06.
Which one did you underline?
What's a Z for this? It is 2.06. Right.
Mhm.
Give me the Z for this one here. 0.99609. 0.99609. What is the Z for this probability?
2.66.
2.66.
Okay. I hope everyone we are on the same page regarding reading this table. It's your X-ray. Only statisticians should be able to understand this. So I was saying readings start from this end up to this side. So what it means, if we said 1.23, we went to 1.2, 0.03. This is 0.89065. So what that means simply is the reading from here up to here, 1.23. So this whole reading, we know that this is 50%. Okay, so from here up to here, reading is 0.89, 0.89065. 0.65. So this is the whole reading from here up to here. Okay. So that being said, I need you to find, let's first try together to find the probability of Z greater than 1.23. This is our A. Our B, Z is less than 2.06. So let's try step one, we illustrate. Okay, we go here, 1.23 is on the right side. The sign greater means we're shading on the right. So when we shade on the right here, we want to look for this shaded region. When you read 1.23 from our tables, what was the reading for 1.23 from the tables? Let's go to our tables. For 1.23, we check in the table 1.23. 1.23 is 0.8907. 89065. That is a reading. So this means that from here to here is 0.89065. So we know that the area under the whole graph is 1. So to find this small reading here, we're simply going to say our Z greater than 1.23 will be 1 minus 0.89065. So here we're going to have what? 1 minus 0.89065. So here we have what? 0.1095. So this is what it means. If the reading from here to here is 80%, how do you find the remainder? We subtract 1 or 100 minus 8. When we go to this second reading here, we are told to find probability that it is less than 2.06. The sign less will tell you that you're shading to the left. This is a part that we are shading. We need to know when to subtract from 1 and when to read directly. If the reading is small, we subtract from 1. If the reading is big, and using the cumulative table, we read directly. So when we go into the table, check 2.06. So 2.0 and under 6, what is the reading? 0.9803. 0.9803. So in this case, I'm not going to subtract from 1 because that is a what? A big chunk. This is a big area. So here we're going to have 0.9803. Subtracting. So now I want you to help me find what is probability of z is greater than 1. What is the probability the lead is z less than 2? So who will start first? Ladies. First step, what we do? X is greater than 1, we illustrate. So when we illustrate here, 0 is there. Where is 1? On the right side of what? 0, and you put your divider. Which side are we shading? The left side or the right side?
The right side.
Right
The
side.
right side.
Okay.
The right side.
Why are you shading on the right side?
That
Because-
the value is greater than 1.
Because of the sign which says greater. Then what's the next step? Even before we read from the table, the next step is to read from the table. What is the reading for 1? That's true. What is the reading for 1? 1.0. What is the reading? What is the reading?
0.412.
0.
3412.
641.
3413.
Okay. Using the other table, yes. So 0.8413. All right. So meaning the reading from here up to here, it is 0.8413. So how do we get this reading, the shaded part here?
Subtract it from 1.
We subtract it from 1. So 0.8413. Okay, the other table will give you 0.3413. Using the half table, you subtract it from half, which is 0.5. Using the full table, you subtract from 1. So 1 minus 0.8413, what do we get?
0.1587.
0.87, correct. Now the gents here, step 1, illustrate. Where is the clue? Our clue is here. Which side are we shading? The left or the right?
Less than 2. The right.
Which side are we shading?
Left side.
Left side. Why? Because the sign said less than.
Left side.
And we identify the reading for 2. What is the reading for 2? 2.0, what is the reading?
9.772.
Okay. So 0.9772. Okay. So this whole reading from here up to here is 0.9772.
72.
So do we subtract from 1 or we read it direct as it is?
Direct.
Huh? We read direct because the shading is big. All right. We read it directly because our shading is what? Big. Okay. So sometimes you'll not be given the values of Z. We'll just give you the mean is 10. The standard deviation is 3. They ask you at A, find the probability that X is greater than what? 16. At B, find the probability that X is less than 13. And part C, find the probability that X is greater than 6. So you need to follow the 4 steps. Step 1, illustrate. Here we don't have values of X. Okay? We don't have values of Z. So we need to standardize. So here the values of X are in here, this line. These are values of Z. Our X is the mean. The mean is always in the middle. X is 16. So let's put 16 here and put our divider. So it's saying greater than 16. So in this shade, we're going to shade on the right because of the sign it says greater. But we don't know what this 16 is. We need to convert it to a Z that we read from the table. So how to convert to Z? Use this is equal to X minus mu for standard deviation. So X minus mu, or X is 16. 16 minus 10 divided by 3. We want to convert this to Z. So 16 minus 10 is 6. Divided by 3 is 2. So this X is equivalent to 2. So if we're checking in the table, we're going to check under 2. So what is the reading for 2? When we go into the table here, we take under 2.0, 0.9772. I mean, the reading from here to here is 0.9772. So to get a shaded region, because the region is a small region, we're going to do what? Subtract. So Z is greater than 2. We're going to subtract 1 minus 0.9772. So when we subtract that, we get 0.0228. Okay, so this is like a recap of what we had. During the week. How about X is less than 13? Step 1, we illustrate. So our 10 is here. Where is the 13? 13 is on the right side, and you put the divider. Which side are we going to shade? On the left or on the right?
On the left.
That's why.
You're saying X is less than 13, so
we're going to shade it on the left.
below 13.
Correct. We standardize this. What's the formula for standardizing? X minus mu over standard deviation. So 13 minus 10 divided by what? By 3. So we're going to get 3 over what? 3, which is 1. So this 13 is equivalent to 1. So we're going to read in the table the reading for 1. What is the reading under 1? 0.8413. 0.8413. So this is 0.8413. Are we going to subtract from 1 or we're going to read directly?
read direct because it's the area to the left.
Yes, we're going to read directly because it is the area to the left. That's true. So we're not going to subtract, we're going to read it directly. Okay. So the reason why we're reading directly is because now suppose we have x is greater than 6. We're going to illustrate this here. Our 0 is here and our 10. Where's the 6? Based on the 10 on the left side here. You put your divider. Greater than 6. So we're going to shade on this side. So we standardize this 6. It is x minus mu over standard deviation. So 6 minus 10 over 3, which is negative 4 over 3. What do we get? Our z will be negative 1.33. Negative 1.33. So you can do it in two ways here. We know that this shaded region is big, so we get a bigger probability. We can read it directly there if you're using the positive values. So 1.33, read it directly. Or when you go to this table here, 1.33, what is the reading for 1.33? 1.33, what is the reading? 0.9082. 9082. So you can simply say this is 0.9802 because we've read directly from this table here. If you're going to read on the negative side, 1.33, 1.33 somewhere here, 1.30123. You get this one here because this is meaning 0.0918. So it will give you the reading from here, 0.0918. So if you're getting this small region here, would have subtracted from 1 because you're using the negative side of the quadrant. Now, I want us to try the text question together. Let us try this together. Here's a question. Suppose a certain retail store has customers whose ages are normally distributed. The mean is 7.5 and the standard deviation is 7.6. What is the probability that the randomly selected customer is more than 48 years old? So what do we do here? What are we given? Our mean is what? 7.5. Our standard deviation is what?
7.6.
7.6. Then one of the questions is asking us to find more than 48. More than is the same as greater than, right?
Yes.
They're asking us to find x is greater than what?
48.
48. Right? So we illustrate. Okay. So here we have what? 7.5. And here is what? 48. So try to calculate. So calculate the values of x. Calculate.
Yeah, so it will be z is equal to x minus mu over standard deviation. Then it will be 48 minus 37.5 over 7.6, which will give us 10.5 divided by 7.6. And the z value, the z score is 1.38. Positive.
Okay, so this is what you said, right?
Yes, sir.
Okay, so what was the z?
1.38.
1.38. So what do we do to the 1.38?
We read that number on the tables.
Read from the tables, and what we find? 1.38.
91.91621.
1.38.91621.
Yes.
Okay.
So that represents the area to the left. Then we subtract 1 minus the area to get the probability of x being greater than 48.
Okay, so this is what we have here. Our mean is the 7.5 and our standard deviation is 7.6. So here we're being asked to calculate the probability that customer is younger than 44. So younger is synonymous to what? Less. That's why using less there. Now, which side are we going to shade? The left side or the right side of 44? Which side? I can't hear you. Is my network bad as well?
The left side.
Left side.
The left side.
Towards 36.
So this shaded region on the left side, what does it tell you? It's big or it's small?
Small.
Small.
Are you sure? If it's small, the answer will subtract from 1. If it's big, you read it directly. So is it small or it's big?
It's big.
Big, yes. So how do we standardize this 44? What's the formula for standardization?
Z is equal to X minus mu divided by standard deviation.
Okay. So 44 minus 37.5 divided by the standard deviation is what? 7.6. So what do we get? Zero point 855. You round off to the nearest 2 decimal places so that you read it properly. 0.86. So when we go to the table, what is the reading for 0.86? What is the reading for 0.86? We go under 0.8 and under 6. You get 0.80511. 0.80511. So reading from here to 0.86, giving us 0.80511. So meaning we can safely say that the probability x is less than 44 will simply be 0.80511. Okay, we'll continue our class in the evening, our revision classes continue for those of you who are writing on Sunday, so that we can cover 3 sessions or so.